Molar mass is a number that we can get from the periodic table, and we can use that number to convert back and forth between moles and grams, or grams and moles. And remember that a mole is something that allows us to convert between the microscopic world of atoms up to the laboratory world where we can measure things on a scale. I introduced the concept of molar mass in my previous video, but I want to spend a little more time on it now because in the previous video we were looking at the molar mass of single elements. Now I want to look at the molar mass of whole compounds. So, for example, if you were asked to find the molar mass of nitrogen dioxide, NO2, you would want to find nitrogen and oxygen on the periodic table and add their masses up. So there was one nitrogen in NO2. It has a mass of 14.01. 1 times 14.01 is 14.01. There are 2 oxygens in NO2. So this 2 right here is going to get multiplied by the molar mass for oxygen, or the average atomic mass for oxygen. 2 times 16 gives me a 32. When I add those 2 together, I have a total molar mass for this compound of 46.01 grams per mole. So when you're dealing with molar mass, the units are grams per mole. This is a conversion factor. It's something we can use to convert back and forth between grams and moles. Because it's a conversion factor, you can write it as 46.01 grams per mole, or you can flip it where the 46.01 is on the bottom and think of it as 1 mole per 46.01 grams. So just to recap so far, we're adding up the numbers, the average atomic masses off the periodic table. These are going to have a unit of grams per mole, and it's a conversion factor that's flippable. We're going to spend a few minutes practicing calculating molar mass, and then we'll take a look at how you can use it as a conversion factor. Here is some molar mass practice. To begin with, find the molar mass of chlorine. Remember that chlorine is a diatomic, meaning it has a 2. So the subscript of the 2, I need to multiply 2 by the number for chlorine off the periodic table. So I said 2, because that's the subscript, times 35.45, which is the molar mass off of the periodic table. That gives me 70.90. That is in units of grams per mole. The next one, find the molar mass of calcium nitride. Calcium, there are 3 of them, so 3 times the number for calcium off the periodic table, which is 40.08, is 120.2. That's for calcium. And then for nitrogen, there are 2 nitrogens, times 14.01 off the periodic table gives me 28.02. Add these 2 together. Calcium nitride has a total molar mass of 122.2 grams per mole. Finally, we have calcium phosphate. Calcium phosphate has 3 calciums and 2 phosphates. This 2 gets distributed inside the parentheses. So you're going to see that there's going to be 3 calciums, 2 phosphoruses, and then 2 times 4, which is 8 oxygens. So when you add that up and use the numbers off the periodic table, 3 times 40.02 gives me 120.2. 2 times 30.9 gives me 61.94. And then remember that these numbers got multiplied. So there were 8 oxygens times the 16 off the periodic table gives me 128. Add these 3 together, calcium phosphate has a total molar mass of 310.1 grams per mole. Next, we'll see how we can use this molar mass as a conversion factor to go back and forth between grams and moles. Here's an example question. How many grams of calcium chloride are in 0.325 moles of calcium chloride? So you want to start always with the number and the unit that you're given in the question. So 0.325 moles of calcium chloride is the first thing that I'm going to write. At this point, I want to switch from moles 2 grams. Now I can do that using the molar mass off of the periodic table. That is a conversion factor that allows me to make that switch. So I'm going to calculate the molar mass. I find calcium on the periodic table. I have 1 calcium in my formula, so 1 times 40.08 is 40.08. I have 2 chlorines in my formula. 2 times the number for chlorine off the periodic table, 35.45, gives me 70.90. Calcium chloride has a molar mass of 110.98 grams per mole. That is a conversion factor that can be switched. I can write it as 110.98 grams per 1 mole on the bottom, or I can have 1 mole on the top divided by 110.98 grams. So the process of whatever unit I start with here goes on the bottom here is what's going to dictate how I write that conversion factor. So since I started with moles, I want moles to cancel out. I'm going to write this conversion factor so that moles is on the bottom and my 110.98 grams is on the top. At that point, everything is set up so that my units are going to cancel, moles cancels, and I end up with grams left over. My final answer is going to be in grams of calcium chloride. So I'm going to take my calculator and multiply by everything on the top, divide by everything on the bottom. 0.325 times 110.98 divided by 1 gives me 36.1 grams of calcium chloride. If this had been a question where we had started with grams and were calculating to moles, I would have ended up with this conversion factor being flipped. So this is just an example of how you can use molar mass to convert from moles to grams or from grams to moles.